Okay, let's continue with this question. You can see that there's a table there showing 3 substances, S, I, and N, with their melting points and boiling points. So you must understand the significance of the melting point and the boiling point. Okay, melting point is the temperature where the substance changes from solid to liquid. And boiling point is a temperature where the substance changes from liquid to gas. Okay, firstly, when you see such questions, you must understand what are these two, melting and boiling point. Okay, some students, they are frightened by negative numbers. So negative numbers mean less than 0. So in other words, for example, substance S, right, its melting point is -8. So you must imagine that from 0, right, so 0 become -1, -2 until -8. Okay, that's why at -7, okay, -7 is a higher temperature than -8. -9 is the temperature lower than -8. So if you want to keep substance as a solid, right, minimum you must be less than -8 because it melts at -8. So -9, substance S would exist as a solid. So you mentally tell yourself, hey, substance S is only a solid when it is very cold, okay, -8 degrees and below. Okay. So now the room temperature, you highlight this, is 24 degrees Celsius. Okay, Dr. Clement worked in the NUS laboratory with a temperature of 24 degrees Celsius. He was able to store 1,500 ml of a substance in a container with a capacity of 800 ml. So when you read this immediately, you must come to your mind that this must be a gas. Okay, because you write down this must be a gas. The reason is because only gas can be compressed. So he can store 1,500 into an 800 ml container. Okay, so which substance did he store? And you have to explain your answer. So in order to exist as a gas, right, so you must look at the column, which is the boiling point. Okay, so which substance will become a gas at 20 degrees? So there's only one answer, because substance N, okay, boils at 20 degrees. Okay, boils mean it change to the gas. Okay, that's mean at 19 degrees, N is still a liquid. Okay, but the next temperature at 20, substance N become a gas. So for this question, this is how you should answer. Okay, I have a prepared answer earlier, so I just copy and paste here. Okay, substance N at 24 degrees, N will exist as a gas because it boils at 20 degrees. As a gas, it does not have a definite volume. Okay, because gas, the properties doesn't have a definite volume. Hence, 1,500 ml of it can be compressed into the 800 ml container. So this answer. Okay. For this one. Okay, next. So basically, the examiner will be looking for this part. Make sure you identify the correct substance, and then you explain why is it a gas, because it boils at 20 degrees Celsius. Okay, then second property, because 1,500 can be compressed into 800 ml. Only gas can do that. Why? Because gas does not have a definite volume, no definite volume. Okay, does not have a definite volume. Okay, next question. Look at this wire mesh basket. It has holes. Okay, would he be able to store S and I? Okay, there were 3, and now they narrow down to 2 into the wire mesh at the laboratory's room temperature. So you must ask yourself, if I want to store something inside here, right? The substance must not be liquid, right? Otherwise it will flow through the hole. Also cannot be gas, it will escape to the surrounding air. So which of these substances will exist as a solid? Okay, as a solid. So you can annotate yourself, this must be a solid at 24 degrees Celsius. So look at this. So you look at the melting point. Okay, which substance melts above what? The 24 degrees. There's only one, right? It's 450, right? Yeah. Okay. So that's mean between I, because they only ask you to I and, will he be able to store I, S and I? So he can only store what? I, right? Because S will become what? Liquid. Okay, this is how you answer. So for this question, I will do it here. Okay. He can only store substance I because at 24 degrees Celsius, substance I would still be a solid, but S would be a liquid. Hence, since it melt at -8, okay, S would flow through the holes of the basket. Okay, this is how you answer this part. Let me put it here. Okay, so he can only store substance I because at 24 degrees Celsius, I, the substance or substance I would still be a solid. Okay, because it melts at 450. Okay, it's still a solid. But S will be a liquid. So it will flow through. Okay, let's continue. Okay, this one I will screen share and then send it to you later. Anyway, you can visit my YouTube to do the revision. Okay, this one also about heat, heat transfer. So I will do this question before I stop the recording. Okay, in this question, there's this part, the sleeve Y. Okay, if you buy hot drinks from certain restaurants like Starbucks, they give you this sort of sleeve Y. And sleeve X is cheaper because it costs more to make this corrugated up and down, this part. Okay, so there are removable sleeves. So they sadly found that she could hold onto the cup of hot coffee with sleeve Y longer than X explained. Okay, if you look carefully, right? Imagine you are the person holding the sleeve, right? Let me erase this part. Let's say I draw like your finger touching this part, this surface here, and then touching this surface here. Okay, if you examine carefully, on the left side, right? At here, right? Let me use another color. Okay, at this part, you see the sleeve X touches your whole skin surface. Whereas if you use sleeve Y, certain parts of your skin surface is above the air gaps. Okay, so they asked you, she found that she could hold on to the coffee using sleeve Y longer. So you must explain in terms of this one, sleeve Y. So this one you should say that using sleeve Y, right? The sleeve Y has what? Lesser surface area in contact with her finger. So less heat will be transferred to her finger. Hence, she could hold on to the hot coffee longer. Okay, this question is from ACS Junior, last year's prelim paper. Okay, I'll let you try first before I share with you the answer. You try to answer yourself first and then compare my answer with yours. Okay, let's return back to the questions. So for part A, right, you must mention about using sleeve Y, right? There is lesser surface area in contact with your finger than in using sleeve X. So there'll be less heat will be transferred, right? Using sleeve Y, so she can hold longer. Okay, next, this part, the double glass wall. So you notice here, there's air here. So you must understand the property of air. Okay, air is a poor conductor of heat. So Sally was told that a double walled glass would keep a cold drink cold for a longer time than a single wall glass. So this one you can annotate by writing, like, for example, in an environment, right, maybe it's 27 degrees Celsius. Okay. And the cold drink maybe is at 7 degrees Celsius. Okay. Example, just a hypothetical example. So both the drinks are 7 degrees Celsius. Okay, heat always flow from higher temperature to lower temperature. So what happens is this will cause it to gain heat. Okay. Okay, but you notice there's a layer of air, right? So air is a poor conductor of heat. It would cause the liquid here inside, right, the double glass wall, to gain heat slower. Okay, so you must mention that air is a poor conductor of heat. It would allow the cold drink in the double wall glass to gain heat slower from the surrounding warmer air than the single glass wall. Therefore, the cold drink can be kept cold for a longer period of time. Okay, now they change the situation. They ask you to state an advantage. They say, why is it good of using a single wall glass instead of a double glass to contain a hot drink? The hot drink, I want the drink to cool down faster. So if you use hot drink, right, change scenario. So now let's say it's become 70 degrees Celsius. Okay, change the drink. 70 degrees C. Same thing. 70 degrees C. Okay, so if you put in the single wall, because now the temperature of the drink is higher than the external. So what happened? It will lose heat. So this one, it will lose heat to the surrounding because heat flows from higher temperature to lower temperature. So by using the single wall glass, right, the hot drink can lose heat faster to the surrounding. Therefore, the person can take the drink, the drink that is cooled down at the shorter period of time. So now I share with you the answer key for the part A, B, and C. This is the full solution. If you look here, I will screen share this and send to you. So part A, you mentioned this part. Sleeve Y has less surface area in contact between her hand and a cup of hot coffee as compared to sleeve X. Okay, when using Y, her hand gained less heat from the hot coffee, and she's able to prevent her hand from getting burned. Hence, she's able to hold on the cup of hot coffee with sleeve Y longer than X. Okay, actually, this answer is quite lengthy. Okay, what you can do is, if you can't write such a long answer, right, you write in point form. You just say that sleeve Y, lesser surface area in contact with her hand. So her hand gain less heat from the hot coffee. So those are the underlying part are important. Okay, gain less heat from hot coffee. So she's able to hold on to the cup with sleeve Y longer than X. Okay, these are the important points. Okay, in case you can't write such a long answer, you just write the part which I told you earlier, lesser surface area, this part. Okay, and then gain less heat. Okay, and then able to hold onto the cup longer. Okay, then part B, the double glass wall one. The double wall glass has air-fuel gap. Okay, this one important. Air is a poor conductor of heat. This is a property. So the cold drink in the double-walled glass gain less heat or gain heat slower. I prefer you write this one. Gain heat slower from the surrounding as compared to the single-wall glass. Okay. So you must mention air is a poor conductor of heat, then you would allow the cold drink to gain heat slower from the surrounding compared to the single-walled glass. Okay, part C now is using the hot drinks, right? The single-walled glass does not have a layer of air trapped, unlike the double-walled glass. So this is an important part. Using a single-walled glass, the hot drink will lose heat faster to the surrounding. Okay, will lose heat faster to the surrounding. So this part I would screenshot and then send to you later after the recording has paused. Okay, so this is the answer key for these questions, which I've just explained. And then I will go on to the next question shortly.